All right, so we're going to continue on whether the functions are one-to-one. If they are one-to-one, then they do have an inverse. And then we're going to find the inverse at the end of this lesson here. But first we're going to see and compare if one function and the other function are inverses of each other. Now there's one way to test it, and a lot of SAT questions ask you to describe this method. The easy method is find the inverse of that and see if it's that. That would be easier, but I want to show you how to find out if these two are inverses of each other by making sure if you do the composite function, start off with f of g of x, which means you're going to plug in the g function into the f function everywhere there's an x. So this function would go in right in there for x, and see if you can simplify it down to just being plain old x. Then you're going to turn around and take the f function and plug it into the x value of the g function, simplify it, see if you get just plain old x as a result. If both of them reduce down to just x, then they're inverses of each other. Okay, so let's start off with that. Let's go f of g of x first, which means I'm plugging the g function, the cube root of x plus 1, right in there. Okay, so here is your f function, and I'm plugging in the g function into it, and then I'm going to simplify this. Anytime you raise a power to the index number, like the cube root of this cube, it just cancels it away, leaving you with x plus 1, and then we have minus 1. So those two cancel, leaving you with a simplification of just x. That's what you want. If it doesn't simplify to plain old x, then they're not inverses of each other. So let's turn around and do g of f of x and make sure that you get a simplification to just x. Now we're going to take the f function, x cubed minus 1, and plug it in right there. Okay, now when you simplify this first, minus 1 and plus 1 is 0. Then if you simplify the cube root of x cubed, what does that do? What is the cube root of x cubed? X. So they both simplified to x, so yes, these are inverses of each other. Okay, so they have to simplify to x, both parts. If you start out with one not even simplifying to x, then you can stop right there and say, no, they're not inverses of each other. Okay? Okay, so let's do a couple more. Are f of x and g of x inverses of each other? We have to do the composite of both. So let's start off with doing f of g at x, which means you're going to take the g function and plug it in right there. Okay, so here comes the g function. And then continue to write that f function. So this is substituting the g function, which is this, into that x right there. Now we're going to simplify and see if we get x as a simplification. So we're going to distribute that. Half of 4 is 2. 1/2 times 3 over 2 is 3 over 4. Now, if I simplified this, it doesn't reduce to x, because this is 4 over 2 plus 3 over 2 is 7 over 2. That does not reduce to x. So no, these are not inverses of each other. Has to reduce to plain old x. That reduced to negative 3/4 x plus 7 over 2. So that's definitely, they're not inverses of each other. So you didn't even have to test the other way around because the first one didn't even reduce to x. Okay, let's look at this last one and see if these reduce to x. Okay, so I'm going to take the g function and plug it in right in there for the x in the f function. Okay, so here's the x part. So this is where I plugged in for the x. Negative 2 over x minus 1 was the g function. It goes right in there. Then I have the plus 1. Now, negative 1 plus 1 cancels. So really what I have is negative 2 over x. Well, I'm dividing by a fraction. Remember, if you divide by a fraction, you keep change flip, right? You keep the first one, you change to multiply, and you flip that fraction. Now we can simplify. This cancels this. Negative times a negative is a positive x. So it did reduce to x on the first time. So now we got to test to see if g of f of x also reduces to x. Okay, so now I'm going to turn around. I'm going to take negative 2 over x and plug it right in there. Okay, so at this point I can do keep change flip on this fraction before I do the subtract 1. So I'm going to take negative 2 and multiply it by the reciprocal of that, which is going to be x plus 1 over negative 2, because I'm dividing a fraction. Now this will cancel with this, leaving me with x plus 1. Then I have minus 1, and those two cancel, leaving you with x. So yes, these two are inverses of each other because they reduced down to just x. And that is how you tell if two functions are inverses of each other. Now, if you're looking to see if a table of values are inverses of each other, all you have to do is switch around the x and the y in the table. If you switch around the x and the y, it has to be the exact same number. You can't change any signs or anything. So here we're going to compare if these two tables are inverses of each other. Okay, so in order for the f of f function and the g of f function to be inverses, you have to switch the x and the y around, and you can't change any signs. So if I switch this y and this x, I should get negative 8, negative 2. Is that what they did there? No. So, and here, if I switch those two around, I should still get negative 1, negative 1. That's not what they're putting here. So, no, this is not, they're not inverses. They have to switch the x and the y exactly as shown to be an inverse. Now they're going to ask you to do that to a section of a subset of ordered pairs. So if I'm going to write the inverse, this is the notation for inverse, f negative 1. That's telling you that this is the inverse of that f function. Okay, so I'm just going to switch the x and the y around on each of those, and this is what the inverse would be in this. 1, negative 2, 0, negative 1, 1, 0, 2, 1, and then 2, 2 again. That would be the inverse of that relation.
Wait, so for that one up there, the example 4 one, would it be exactly the same numbers, or would it
have to be the exact same numbers?
So negative 2.
Negative 8 would have to switch. It'd have to be negative 8 and negative 2. Well, they wrote positive 8.
Wait, so negative 2 would still be an x?
If you switch this around, the table should be negative 8, negative 2. That's not what they did there. They wrote 8, negative 2. So that's not an inverse if you change the sign. Okay, what about function g? What would be the inverse of function g? So we would just switch the x and the y. So this would be 1, 3, 2, 0, 3, 2, and 0, 4. So those are pretty easy.
There's video on the
Yep. Right now. Okay, last part of the 4-1 is actually taking an equation, seeing if it's 1 to 1 like you did yesterday, and then if it is, then find the inverse. So what you're going to do is determine whether the equation is 1 to 1. You did that yesterday. You should know how to do that now, but I'll remind you. And if it is, you're going to find the equation of the inverse. How do you do that? You switch the x and the y around, and then you solve the equation for y. Then we're going to talk about what the domain and range are of your inverse. Okay, it should be pretty easy. All right, so let's see. Is letter A, f of x equals 2x plus 5, is that a 1 to 1? Yes or no? What is y equals, because really this is your y, what is y equals 2x plus 5? What kind of function is that? It's a line that goes slanted. Is a line that's slanted a 1 to 1? Yes, because it passes the horizontal line test. So I know there's an inverse. So to find the inverse, you're going to switch the x and the y around in the equation. So now this is x and this is y in the equation. And you're going to solve for y. So get y by itself after you've switched them. So now I'm going to subtract 5. And then divide by 2. So you get y inverse is equal to, this is really 1/2 x when there's no number up there, and negative 5 over 2. So the inverse happens to be a line as well. So we're going to state the domain and range of the line. Well, the domain, there's no restrictions for x, so they'll be all real numbers. And the range, there's really no starting point on the y. It's going in both directions. So the range also is all real numbers. So they're going to ask you to state the domain and range of your inverse function that you make up.
So inverse, like
Right. Yep. Like a parabola, if you drug, because it starts somewhere and goes, both of them go in a different direction, then there would be a starting point. Yep. Okay, let's look at letter B. First determine, is it a 1 to 1? What is y equals x squared plus 2? What does that represent? A parabola going which way? Up is a parabola going up. Sketch it. Does that pass the horizontal line test? Nope, because it hits it twice. So there is no inverse when it's not a one-to-one. So that's what you write in your answer. You don't even have to do any work. There's no inverse.
No.
So first determine, does it have a one-to-one? If it does, then you can start the process of finding the inverse. If it doesn't, then you just write there is no inverse. Okay, last two. What is y equals x minus 2 raised to the third power? What does that look like? Third power. Goes like that. Is that what you're drawing in the air? Okay. Is that a one-to-one? Yeah. Horizontal line test hits it once. So I know that there is an inverse. So I'm going to find the inverse by switching the x value and the y value. So this becomes a y now, and this becomes the x. And I'm going to solve for y. First thing I got to do is get rid of this cubic. How do I get rid of this exponent? What do I need to do? What's opposite of that? Do you remember? Cube root. Whatever the exponent is, that's the root that you cancel it with. So if it's a cubic, this would be a third root. If that was a fourth power, that would be a fourth root. But what you do to one side, you have to do to the other. So this side has to be x cubed. And then this cancels that, leaving you with y minus 2. Now all I got to do is add 2. I'm sorry, this should be a cube root. Add 2 to the cube root of x, and that is what your inverse is. The cube root of x plus 2 would be the equation of the inverse, which is just moving this on its side, so it kind of look like that. So, is there a restriction for x? In other words, is there anything I can't put in there and take the cube root of? You can take the cube root of a negative, by the way. So there is no restriction for x on a cubic. So the domain would be all real numbers. And the range. If this is what the graph looks like, there is no starting point on the y. And it goes on in both directions. So it's also all real numbers because there's really no real starting point along the y because it's going in like a linear function. Okay?
Where did you get the -1?
Well, that's just a notation for inverse.
Okay.
So if that notation says I'm finding the inverse of the y, and that's what it would look like.
Okay. So I just put
Yeah, it's just a notation. Saying this is my inverse, that's what I'm...
If the graph looks like how the
No, there would be all real numbers for that range as well, because there's really no starting point. Okay, look at letter D. Is this a one-to-one? We just graphed that in the last chapter. What's the horizontal, what's the vertical asymptote here? -2. Horizontal is 0, because that's the K. It's a positive fraction, so what quadrants does this graph in? 1 and 3. Is this a one-to-one? Does it pass the horizontal line test? Yes. So I know there is an inverse. So I'm going to switch the x and the y. There's the y. Now it becomes x. And then that one's going to be the y. Now, if I want to solve for y, I have to get it out of the denominator. it's being divided, so to move it, you multiply. And I'm not even going to make you multiply anything. Don't multiply anything. Show it as being multiplied on that side next to the x. Okay, so the first thing I would do is divide by the x because it's being multiplied. Get rid of it. Now all I gotta do is add 2, subtract 2 and put it on the end. So my inverse would be 3 over x minus 2. Now, you remember the domain and range follow the vertical asymptotes and the horizontal asymptotes. The vertical one is 0 because it's undefined when x is 0. The horizontal is the k. So your domain would be x cannot equal 0, and the range would be y cannot equal negative 2. Okay, so think about that. A lot of this will be stuff that you've learned and we're building on.